Okay, hi and welcome to your ENG 6203, Engineering Economics. This topic discusses week 4, money, time relationship, and equivalence. Okay, so objectives. At the end of this module, the learner should be able to differentiate present value from future value, calculate simple and compound interest, find the corresponding effective rate, and determine the future worth of a present value or the present worth of a future value. So before we start, let's define first interest. Okay, what is interest? Interest is the amount of money paid for use of borrowed capital. So it's also the income produced by money which has been loaned. So example, you borrow money from a bank. So there will be a corresponding interest for a year based on the agreement. So you are going to pay the bank after a year with the amount you loaned plus the interest. Okay, so another example is, if you deposit a certain amount in the bank, okay, there will be an agreement also that your money will earn an interest after a certain period of time. And that will be your total balance in your account. So the amount you deposit plus the interest. So the first type of the interest is simple interest. Okay, it is calculated using the principal only. So ignoring any interest that had been accrued in preceding periods. Okay. So in practice, simple interest is paid on short-term loans in which the time of the loan is measured in days. So the formula is interest is equals to P times N times I, wherein your I is your interest, your P is your principal or present worth, your N is equals to the number of interest per period, and I is the rate of interest per interest period. And of course, your F is the accumulated amount for the future worth. So again, your formula for I is equals to P multiplied by N multiplied by I. Now, for getting the F, F is equals to P plus I, where it is also equals to P plus P times N times I. Okay, so by factoring out the P, okay, the formula now for F or the future worth is equals to P multiplied by 1 plus N multiplied by I. Okay, we have two types of simple interest. Okay, the first one is the ordinary simple interest. Okay, it is computed on the basis of 12 months or 30 days each month for 360 days a year. So this is fixed. So one interest period is equals to 360 days. The other one is the exact simple interest is based on the actual or exact number of days in a year. 365 days for ordinary year and 360 days for a leap year. So one interest period is equals to 365 or 366 days. Then we also have the cash flow diagrams. A cash flow diagram is simply a graphical representation of the cash flow drawn on time scale. So cash flow diagram for economic analysis problem is analogous to that of a free body diagram for mechanics problem. So example, we have the receipt. Okay, positive cash flow or what we call the cash inflow. And when we say there's disbursement, it is a negative cash flow or cash outflow. Then we have the compound interest. Again, formula F is equals to P, okay, multiplied by multiplied by 1 plus I raised to N. Okay, so you're going to get the P, it is equals to F multiplied by 1 plus I raised to negative N. Okay. So we're in again, the P is the principal or the present worth. The M is equals to number of compounding periods in 1 year. N is equals to M multiplied by the number of years. And I is equals to R over M. Again, your F is the accumulated amount for the future worth. So the quantity 1 plus I raised to negative N, okay, is called the single payment present worth factor. So, and it is designated by the functional symbol P, F, I%, and N. Okay, thus, this is the formula now. P is equals to F multiplied by PF, I%, and N. Okay, or the symbol PF, I% and N is read as P given F at I% in N interest periods. rate of interest, okay? We have the nominal rate of interest. So I is equals to RM, okay, where I is equals to rate of interest per interest period. Your R is the nominal rate, and M is the number of compounding period per year. Example, if the nominal rate of the interest is equals to 10%, okay, the compounded quarterly is then your I is equals to 10% divided by 4. Why? Why 4? Because this is compounded quarterly. Quarterly means 4. So your interest now is equals to 2.5%. Okay. Okay, let's have the values. Values of M. Okay, annually it's equals to 1. That's per year. Semi-annually, okay, that is equal to 2. Quarterly 4, semi-quarterly 8, and monthly is equal to 12 because we have 12 months per year. Then we have the effective rate of interest. So effective rate of interest is the actual or exact rate of the interest on the principal during 1 year. So the formula, effective rate is equals to 1, okay, 1 plus I raised to M minus 1. Okay, let's have an example. Determine the ordinary simple interest of 700 pesos for 8 months and 15 days if the rate of the interest is 15%. Let's start with the given. First, let's have the P is equals to 700 pesos, our principal. Okay. Next, the interest is equals to 15% or 0.15. And then our N is equals to 8 months. Okay. 8 months and 15 days. So 8 months and 15 days. Then, of course, let's convert this to days. So since this is simple interest, okay, we'll be using 30 days, fixed 30 days. So 8 months multiplied by 30 days plus 15 days, our total days is 255 days. Okay, then we'll be using the formula. I is equals to P and I since we're looking for the interest. I is equals to P times N times I. Then substitute the values. Okay, P is equals to 700. Then your days is 255 days divided by 360 because this is again simple interest. Okay, so 700 multiplied by 255 divided by 360 multiplied by 0.15 or 15%. So our interest is 74.38. Okay, next example. Determine the exact and ordinary simple interest on a 1,200 pesos for the period from January 16 to November 26, 1992 if the rate of the interest is 24%. Of course, given, we have the principal, which is equals to 1,200. Interest is equals to 24% or 0.24. And of course, N is equals to January 16 to November 26. Okay, that's equal to 350 by 15 days. Okay, and so how did we get that? So from January 16 to 31, January 31, okay, excluding January 16 or just subtract this one. 16 minus 31 is equals to 15 days. Then we have February 29 because this 1992 is leap year. Okay, then for March, we have 31. For April, we have 30. For May, we have 31. For June, we have 30. July 31, August 31, September 31, October 31, and November, we have 26 days, including the November 26. So the total days is 315 days. Again, this is leap year. So again, let's go to the formula. I is equals to P times N times I. For ordinary simple interest, our P is equals to 1,200 multiplied by 315 days divided by 360 days because this is simple interest. Multiplied by 24% or 0.24, so our answer is 252. Now, for compound interest, for exact simple interest, okay, for exact simple interest, we have 1,200. Okay, multiplied by 315 divided by 366 because it is leap year. Multiplied by 24% or 0.24. So the interest is 247.87. Okay, another example. Okay, so find the amount at the end of 2 years and 7 months if 1,000 pesos is invested at 8% compounded quarterly using simple interest for any time less than a year interest period. Okay, so the given, we have our principal, which is equal to 1,000. Okay, again, get your interest. Your interest is 8% or 0.08. Okay, and then M is equal to 4 because it is compounded quarterly. Okay, and then your N is equal to 2 multiplied by 4. Okay, because it's 2 years multiplied by quarterly. So 2 years multiplied by quarterly is equal to 8. Okay, so for compound interest, your interest is equal to 0.08, okay, divided by 4, okay, compounded quarterly, and your N is equal to 2 years. For simple interest, okay, our interest is 8%, okay, and our N is equal to 7 over 12 because this is less than 1 year. Okay, the fixed interest for 2 years is 8%. So let's start with F1. F1 is the compound interest. This one. We'll be using this one. So F1 is equals to P, okay, multiplied by 1 plus I raised to N is equals to our principal is 1,000 multiplied by 1 plus this is 0.02. Okay, because of this. 0.08 divided by 4. So our interest now is 0.02. Okay, raised to 8. Okay, is equals to 1,171.66. Okay. Okay, raised to 8, your N. Now for F2, our formula is equals to F1 multiplied by 1 plus N multiplied by I is equals to 1,000, our F1, 1,171.66 multiplied by 1. Okay, our N is 7 over 12 multiplied by 8%. Okay. So the answer is our F2 is equals to 1,226.34. So let's move. Okay, another example. A 2,000 loan was originally made at 8% simple interest for 4 years. At the end of this period, the loan was extended for 3 years. Okay, so after 4 years, then we extend to 3 years. So it's already 7 years. So without the interest being paid, but the new interest rate was made 10% compounded semi-annually. How much should the borrower pay at the end of 7 years? Okay. Okay, our solution. So F4, okay, is the amount at the end of 4 years. Okay, so our interest for 4 years is fixed 8%. Okay, and then N is equal to 4 for 4 years. Now F1, the amount at the end of 7 years, okay, from 4th year to the 7th year, which is 3 years after the 4 years. So the amount of the end of 7 years, now based on the condition, the interest now is 10%. Okay, so our interest is equals to 0.10 divided by 2. Why? Because it is now compounded semi-annually, which is equals to 2. Okay, so your interest now is 0.05 and your N years is equals to 3 years. Okay, multiplied by 2 because it's semi-annually, so it's 6. Your N is equals to 6. Okay. F4 is the present value after 4 years and F1 is the future value after 3 years. So this is the diagram. So first, okay, you borrowed 2,000. So this is the principal. And you have the simple interest until 4th year. And then you continue this until the 7th year using a compound interest. Okay, this is the diagram. So from 0 to 4th year, simple interest. Then from 4th year, to 7th year, this is now compound interest. So, okay, to compute for the F1, the formula is, okay, this F4 first. Okay, first F4 is equals to P, okay, multiplied by 1 plus Ni, N multiplied by I is equals to 2,000 plus 1, okay, 1 plus multiplied by 4, okay, because it's 4 years, and then the 8%. So your total is 2,640 for 4 years. Now the formula for F1 is equals to F4, okay, multiplied by 1 plus I raised to N, okay, wherein your F4 is equals to 2,640 multiplied by 1 plus, okay, 0.005 because it's 10% and semi-annually, so divided by 2, it should be 0.05 or 5% now. And your M is equals to 6 because it's 3 multiplied by 2, then 6. So your F1 now is 3,537.86. Next, find the nominal rate, which if converted quarterly could be used instead of 12% compounded monthly. So what is the corresponding rate, effective rate? So solution, let R the unknown nominal rate. Okay, so we have two. Okay, the nominal rate, R% compounded quarterly is equals to, this is the formula, 1 plus R over M raised to M minus 1. Okay, and for 12% compounded monthly, we have the 1 plus 0.12, okay, for 12%, and then divided by 12 for monthly, raised to 12 because it's monthly, minus 1. Okay. So let's start. So 1 plus R over 4, okay, 4 because it is compounded quarterly. So your R, your M now is 4, and this is also 4. Okay, so we will be using 1 plus R over 4 raised to 4 minus 1 is equals to, of course, your compounded monthly, 12%. Okay, 1 plus 12% divided by 12 months raised to 12 minus 1. Okay, so to eliminate 1, substitute 1 to the other side. Okay, this will now be 1 plus R over 4 raised to 4. So we don't have the 1 anymore. Is equals to 1 plus 0.12 or 12% divided by 12 raised to 12. Okay, now to eliminate 4, this one, we have to divide both sides by 4. Okay, so now we have 1 plus R raised to 4, R divided by 4 is equals to 1 plus 0.12 divided by 12 raised to 3. Okay, raised to 3 now. Next, 1 plus R divided by 4 is equals to, okay, 0.12 divided by 12 is equals to 0.01. Now raised to 3. And then 1 plus R divided by 4 is equals to 1.0303 is equals to R over 4 is equals to 1.0303 minus 1. Okay, we substitute this one on the other side. Okay, so now the value of R over 4 is equals to 0.0303. Now, to eliminate 4, we have to multiply both sides by 4. Okay, so R is equals to 0.0303 multiplied by 4 is equals to 0.1212 or 0.1212. Or it's 0.1212 or 12.12% compounded quarterly. Next, a man bought a lot worth 1 million if paid in cash. Okay, so on the installment basis, he paid a down payment of 200,000, 300,000 at the end of 1 year, and 400,000 at the end of 3 years, and the final payment at the end of 5 years. What was the final payment if the interest was 20%? So let's solution that Q is equals to the final payment. Okay, this is the diagram. So did you notice we only have now 800 Why? Because, okay, based here, okay, if it will be paid in cash, it will be 1 million. But he already gave a down payment of 200,000. So the balance now is only 800,000. Okay, so we'll start with 800,000. Then after 1 year, he paid 300,000 after 1 year. And then on the third year, he paid 300,000. Okay, and here, it's on the first year, he paid 300,000. On the third year, he paid 400,000. This one. And the fifth year, that is now the Q. That's the unknown. Okay, so using today as the focal date, the equation of value is 1. Okay, we have the 800,000 is equals to 300,000. So again, how do we read this? Okay, 300,000 multiplied by P at given F at 20% interest in 1 period. Okay, plus 400,000 multiplied by P at given F at 20% interest in 3 years period. And again, plus Q multiplied by P at given F at 20% interest in 5 years. Okay, so the formula now is P is equals to F. Okay, so P is equals to F multiplied by 1 plus I raised to N. So let's substitute. So 800,000 is equals to 300,000. Okay, our formula is 1 plus the interest. So this is 1 plus 20.20 or 20% is equals to 1.20. Okay, raised to the N or negative N or the year. So raised to negative 1. Next, plus 400,000. Again, the formula is 1 plus I. So 1 plus 20% or 1 plus 0.20 is equals to 1.20 raised to negative 3 or the 3 years, third year. Then we have the Q plus 1.20 also raised to negative 5 for 5 years. So we have now 800,000 is equals to 300,000 multiplied by 0.8333 plus 400,000 multiplied by 0.5787 plus Q multiplied by 0.4019. Okay, so the Q now is 792,560. Okay, that will be all, class, and thank you and have a nice day.